Yes, I can see it.
All right, thanks. Thanks for the confirmation. So this program is called Zero to Lab, and as I have mentioned, you are already, as you mentioned, you have watched earlier introductions as well. That when we were planning this course, Christian and I were brainstorming, and we were thinking, okay, what can we do to make CCIE as approachable as possible? Because what happens is CCIE is a huge task, and there are so many topics to not only just understand but also to master and to become very very comfortable, and to be able to configure them together. When you go to the exam, it's an 8-hour exam where 5 hours of it you have to configure the same topology. You build upon layer 2, layer 3, and then you configure services, you configure VPN technology. So there are so many things you do on the same topology, and you need to make sure that everything is working with each other. All technologies are coexisting correctly, and if layer 2 doesn't work, your layer 3 absolutely cannot work. And same thing, if layer 3 is not working, none of the other services will be reachable. So everything has to be properly configured in a step-by-step manner. So we wanted to make sure that, okay, if somebody is coming from CCNA or CCNP and they want to go to the next level and they want to get CCI certification, what are the current options out there? And most of the things we saw were boot camps. So 5 days boot camps or 10 days boot camps where they go through all the CCI blueprint topics as soon as possible, as fast as possible, uh, covering everything. And yes, they will show you the configuration on a on like a projector, and you will be in a class with 50 other people, and you will be watching the configuration, listening to the instructor, understanding or trying to note down everything. So it becomes quite too much. And the classes are also like 8 to 10 hours, sometimes even 12 hours a day. And then in 5 days, you consume a lot of information, and then you are done. So they might give you the labs after that, that you can do it on your own. But how much time are you going to take to regain all that information, relearn it, or to revision it, and then to start doing the configuration? So we thought, okay, that's actually not a very practical method to get to the CCI. Yes, boot camps can be useful if you have been preparing for some time and you are almost ready for the exam and you just need one final push. You want to do the few laps again. Maybe in that case, 5 to 10 days boot camp can be like a booster to get you to the CCI certificate or give you some extra practice. But for anyone who wants to learn all these technologies in detail, layer 2, layer 3 VPN technologies, SDA or programmability, you need time. You need time for that. And we thought, okay, let's create a program where we will actually go through one technology per week, and we go in depth. We actually make sure that we understand the three fundamental questions. What is the technology? Why do we need it? And then of course the big question, how to configure it. So if you because people are coming to CCI from CCNA, from CCNP, some production experience, or if you are really wild enough, you are coming with very basic knowledge and you're saying, okay, I want to go directly for CCI. Of course you can do that as well. You don't need to pass the CCNA CCNP to become CCI. So there are some people who are fairly new to most of the technologies. So what happens is that when we approach a particular topic in this class, we are going to make sure that we start it from scratch. So even if you are starting something like STP, spanning tree protocol, which is something you learn in CCNA and then again in CCNP, and now again in CCI, it is again covered one more. But we make sure that we start it from scratch again, answering the three fundamental questions. What exactly is STP? So it's a loop prevention mechanism, for example. Why do we need it? Like, what problem is it solving in the world? So the looping is a big problem in the switching environment, and if you don't have redundant links or backup links, then you have a single point of failure. That means there is no fault tolerance. So administrators don't like it. Administrators don't like to get a call in the midnight asking that, hey, there is a network outage and you have to come and fix it. Instead, they like to have as many backup links as possible, so that if there are a few failures here and there, there is still reachability end to end. But as soon as you have backup links, you always have looping issues, and that's why you need STP. So this was just to give you an example, that we start with the introduction of the technology, that what is this and why do you need it? So it becomes much easier or more it makes more sense to understand how to configure it instead of directly jumping to the configuration. And same thing we apply for every single topic. So there will be few topics which you have done before, like maybe routing protocols or a little bit of BGP. But then there might be topics that you haven't done it before, like SDA or SD-WAN or introduction to Python. Or if we are talking about programmability, how actually can we use the netconf and resconf? What are these protocols? Why do we need them? And how do they interact with the routing or switching devices to configure them remotely? And how we can integrate it with Python to make it automated. And what are some of the tools that we use? Like on the CLI, there are some command line tools that we can use, like curl command, curl, or on the GUI side, we use Postman. And these can be used to send the netconf or resconf queries or API requests to the devices. And Cisco itself has a small programming language kind of thing inside the router called EEM, embedded event management, where you can look for some events, and if those events are triggered, then you can take some actions. So we can actually integrate that also with Python language, and then we will learn those things as well. So we will learn all the core technologies which are there into the exam, starting from layer 2, then layer 3 routing protocols, IP version 6, aggregator protocols like BGP, multicasting, quality of service, MPLS, DMVPN, GRE tunnels, IPsec tunnels, and all this IP services that we configure after the infrastructure is already set. For example, NET, DHCP, DNS, NTP, all these services are also very important. SNMP, net flow configuration, but these things only work if your layer 3 is already working, you already have reachability. So there are a lot of core topics also which are very important. And then of course we have some advanced topics, as I mentioned, SDA, automation and programmability. So we created this program for 52 weeks because we want to make sure we concentrate on one technology per week, and then we make sure that we are comfortable with that, and you have the whole week to practice it and have some questions maybe, and then next week we start the next topic. And sometimes of course the topics are big, so we can go multiple weeks as well, like BGP is 6 weeks, so we make sure that we go in depth in BGP, and we don't complete it like in just one session. So having said that, let's see first of all the CCIE exam structure, because the exam that we are talking about is the enterprise infrastructure exam, used to be called CCIE routing and switching earlier. And this exam, earlier it used to be 2 hours of troubleshooting and then 6 hours of configuration. So if you go and take the exam, let's say back in 2012 or 2015, you will see that you have a different topology where you will get 10 tickets, they call it, and there will be 10 troubleshooting questions you need to solve. And to guarantee that you will pass the exam, you should actually fix at least solve at least 9 tickets. You can also pass if you do 8, but the questions were weighted. So some questions had more weight, some had less weight. And then the remaining 6 hours is the configuration. So that's a different topology where some configuration is there and you need to complete the configuration and sometimes even fix the configuration if there is some mistake. So they changed this structure in the new exam, CCI Enterprise exam. So now it is actually divided into two parts. Uh, so of course, the qualification exam earlier used to be a dedicated qual exam. So there was a CCIE qual exam, which you had to pass before you can book the CCIE lab. But now they have integrated this qual certification into the CCNP. So if you are pursuing your CCNP and one of the certification or one of the exam you need to pass for CCNP is NCORE exam. So if you pass the NCORE exam, you are on your way to become CCNP certified. You need to do one concentration exam as well, like NRC or SD-WAN. But just passing the NCORE actually qualifies you to be able to book the CCIE lab. So you don't need to pay extra or prepare extra for a CCIE dedicated CCIE qual exam, which used to be the written exam before. And of course, once you do that, then you go to the lab exam. So the currently active lab exam is in CCIE Enterprise Infrastructure version 1.1. And this exam is still 8 hours, but now they don't have the troubleshooting section and the configuration section, 2 hours and 6 hours. Instead, you have a design section and then you have the deployment section. So you will see that in lab exam, total you get 8 hours, and there is a design part, and then there is a deployment part. So design part is 3 hours now instead of 2 hours. And this is mostly the MCQs, multiple choice questions, drag and drops, or some questions where you have to just theoretically answer it. There will be no configuration or no labs in this part. So this is similar to your CCNA, CCNP certification exams where you have MCQs and theoretical questions or multiple choice questions, right? The thing is that if your fundamental knowledge is strong, the design part will become easier because here they might show you uh, the output of some show commands, and then they will ask you some questions based on that output, or they might show you like an email exchange between a network engineer and a user, and you have to just read that content and then have to decide what could be the possible issue or what could be the possible solution. So the design part directly depends on your fundamental knowledge of the technology. So we'll make sure that we are good enough for this part before we get to the exam and we can easily answer these questions. But just like any other exam, you will need some practice before the exam. So I'll give you some questions that you can go through that time. And it's not that it's not the same questions from the exam. It may be like from a previous exam or maybe a few months ago. But the idea is not to cram anything to pass the exam, but to understand that how Cisco structurize the question, and how it can actually you can actually find out the answers and see the difference between the right answer and the wrong answer, right? And of course, the second part is where you get to the configuration. So the second part is deploy, operate, and optimize. And in this part, you get 5 hours and a different topology. So you will get a topology here where some of the configurations will already be there. And you just need to complete the configuration. Or if there is any issue, you need to fix the issue. Like if they are asking you to configure OSPF in a particular part of the topology, you will see that most of the IP addressing and even OSPF configuration will also be there. So you just need to see if the OSPF neighborship is not coming up between some certain routers or switches, then you need to just fix the issue. So you can see that although troubleshooting is not a part of the exam dedicatedly now, like there used to be 2 hours troubleshooting section, but there will be troubleshooting questions here and there because you don't configure everything from scratch in the exam. There is already a configuration, and you need to just fix it and make it look like how it's supposed to look like when it is properly configured, right? So in this 5 hours, you have three major sections. I actually call them the routing switching or the core technologies. And then of course you have the SDN, and then you have the programmability part. So the first part, section 1, will have all the core technologies that we learn every time, and that's what creates the routing and switching domain. So layer 2 technologies, VLANs and trunking, ether channel, spanning tree protocol, VTP, all these things will be there. And then comes the layer 3. In layer 3, you have the routing protocols, EIGRP, OSPF, BGP, or IPv6 routing protocols. And then quality of service configuration or VPN technologies are also part of it. TMVPN, MPLS, generic routing encapsulation, GRE tunnels, or IPsec point-to-point tunnels. All these will be part of the VPN technologies. Multicasting is also a part of it, and other IP services and security services. For example, as I mentioned earlier, NET, NTP, DHCP, DNS, SNMP, NetFlow, all these things. So this is actually not new, routing and switching part or the core technology part, but this will be the biggest part in the exam. You will see that out of the 5 hours, you will be spending more time into the first section because of its sheer volume, right? There are so many questions and so many configuration that you need to do into this part. Second section is SDN or software defined networking. So in SDN, you can actually implement SDN concept in two different sections. You can do it in a campus network or like an enterprise network, LAN side basically, which is called SDA, software defined access. And you can also implement this logic on the WAN side, which is called SD-WAN, right? Now, what is this concept of software defined networking? We will learn in detail also when it comes to that part. But just to quickly let you know that whenever we decouple the control plane and the data plane, so the brain of all the routing policies or switching policies, any kind of traffic movement policies, you will no longer implement them individually on the networking devices. Instead, you will have a central device which we call controller, and this controller will actually have all these policies created, and then these policies will be pushed to all the end devices or edge devices who are just going to implement them for the data forwarding use cases, right, or data forwarding policies. So whenever you decouple control plane and data plane, and you also decouple the management plane from them, this is called software defined networking, because you can control complete routing and switching policies from central location, right? So if you are implementing it on the LAN side, the controller is called DNS Center, Cisco DNAC. But if you are implementing it on the WAN side, the controller is actually called vSmart, which actually works with the vManage, which is the management plane, or the GUI, single pane of glass, and the vBond, which is the orchestrator, and making sure that only the authenticated devices are authorized devices are connected to your SD-WAN fabric, and also to enable communication between the controllers like vSmart, vManage, and the edge devices that you have. So that is something we are going to learn in depth as well, and we will have many labs for that. And in the exam, although you can see that this is the new part, but one thing you will notice once we reach to that point is that after you understand the logic, it's all GUI. Mostly it is GUI, although there are few things you can do from CLI also, but in the exam, they are expecting you to configure everything from GUI. So it's mostly remembering which option is available where on the vManage or DNS Center. So you should be just familiar with the locations of different options in the GUI plane. Uh, and if the logic is clear, what's supposed to be done, what are the steps, and then where to look for, to be honest, this doesn't take much time in the exam. It takes less time than the core section. Core sections is pure CLI, and it's a lot of information, as I just mentioned, all the technology names. So that's why SDN, although it's scary for people who haven't done it before, or it's new, of course. So comparatively new, I mean. But once you get to understand it and see or become familiar with the GUI, you know where to go for which option. Then it doesn't take much time into the exam. It's actually comparatively faster. And that the same thing goes with programmability. Programmability is the smallest part in the section, in the exam, sorry. It's the smallest section in the exam. But of course, you need to have some knowledge of information about data structures, like what different data structures can be used, like what is the difference between XML and JSON format, how they are different from YAML. So why do we need any data structure? What is the logic behind this? We will understand that part. Also, the modeling language, data modeling language, which is the language used between the networking device and the and your system from where you're making the API calls. So what data Yang data models mean? What exactly is this language? What are the different keywords that we use in this? And of course, what protocols are used to carry this information from the controller to the devices? So, for example, we have netconf and RESTconf. So what these different languages, or gRPC, Google Remote Procedure Call. So what are these languages and how they actually, or protocols, and how they actually interact with the devices? We are going to learn that. And of course, as I mentioned earlier, Python and EEM scripts and some CLI and GUI tools that we use for automation and programmability. So there will be a lot of interesting things we will learn there, and we'll see some practicals as well. But in the exam, if you know the stuff enough, this will be the shortest part. To be honest, 15 to 20 minutes is maximum you need after some practice to complete the programmability part. Same thing I will say, an hour for SDN part. So it all boils down to the routing and switching part. So if you can complete it in 2.5 hours or 3 hours, you will be able to finish the complete configuration well within 5 hours. And that's the idea. You should be able to complete it in 4 hours or 4.5 hours max, so that you get that crucial last 30 to 60 minutes to check everything again. That if you made any major mistake, or did you forget something or skip something? Because what happens is it's a long exam, a lot of configuration, so it is very normal to forget something, or there is a typo or some configuration mistake, and if you get that uh, precious 30 extra minutes in the end to check everything again, you might be able to find that issue and fix it. That did happen to me in my CCIE routing and switching exam. I was checking everything at the last, and I found some major mistakes and a couple of routers, which I of course fixed and saved the configuration. Otherwise, definitely would have failed the exam if I did not have that extra checking time, right? So we will have to plan once our course is finished. Of course, when we say that this is a 1 year course, and this will logically it will prepare you for the exam, but then of course before going to the exam, although you have the accuracy now because you know all this stuff, but you still need the speed, the pace. So for the pace part, some people get ready in 1 week, some need a couple of months to practice in a phased repeated manner, and then they feel comfortable to complete the lab in 3 hours or 4 hours, and they say, okay, if I can finish this year in 4 hours in exam, maybe I will be able to do it in 4.5 hours, because there's an extra element of a real time pressure because you are in the exam instead of just practicing, right? So this is the structure of the exam, and we are going to tackle it by doing in the same particular manner. We will start by technologies like routing and switching technologies, and then we'll move to SDN, and lastly we'll do the programmability. And of course, we will do them separately. So these are called single protocol labs because we concentrate on one technology on a particular topology at one time. But of course, we will also have a couple of multi-protocol labs at the end to see the complete or feel the complete experience or have the complete experience of the exam, right? So having said that, you will see that some of the devices will be partially pre-configured, as I mentioned already, and you will just need to configure the devices, the remaining part of the configuration as per the instructions, right? So just to give you an example here, uh, like this is one of the topology that we'll use for the multi-protocol lab. So similar to what you might see in the exam. So you can see that there are multiple different locations, like we have headquarters, data center, and then we have this service provider network, which is enabling you to communicate or connect to these branches, branch 3 and branch 4. So we will be configuring some tunneling like DMVPN tunnel configuration here. So this is an example of a multi-protocol lab where you need to configure switching, and then you need to configure routing, you need to configure VPN technologies. You will need to configure MPLS VPN into the service provider network, and other services like DHCP configuration, making sure the computers are getting IP address from the DHCP and IP version 4 and IPv6 routing, and some other important stuff like internet access from everywhere. So all these technologies we will configure on the same topology. So it is similar to what you see into the exam, right? So the point I'm trying to explain here is that most of the things will be already configured. So you don't need to worry that, okay, it's such a huge topology. There are so many routers, as which as if I have to configure everything from scratch, it will take a lot of time. But no, that's not the case here, right? For example, when they say in data center, you have OSPF configuration, right? So you will see that OSPF is already configured between all the routers and switches, but there might be few things misconfigured. So you just need to quickly check if the OSPF neighborship is coming up between them or not. If not, then you just need to fix it somehow by finding out the issue by checking the configuration against what's supposed to be there, right? And this is something we are going to learn in depth in our technology part, so that troubleshooting becomes a second nature. What happens is troubleshooting also depends on the fundamental knowledge. Like if the OSPF neighborship is not coming up, you need to know what exactly do you exchange in an OSPF hello message that needs to be same. Like you have to make sure the network and subnet mask is same. The area ID must match. If there is any authentication configured, of course, password must match. MTU must match, but the timers also must be same on both routers, and the type of the area should also be same. So one cannot be a normal area and one cannot be a stub area. They both need to agree that we belong to the same area and the same type of area, normal versus stub area. So when you see these things, and then there are things which must not match, like router IDs must be unique. So when you know what needs to be checked, you can quickly check these things to see what is the issue, why neighborship is not coming up, right? Just to give you an example. And similarly, we will have another multi-protocol lab as well, which will be for SD-WAN. For example, we will have all these controllers, vSmart, vMont, vManage, and then we have the edge devices, VHs, connecting from different branches as well. So here we will see a lot of IPsec tunnel configuration between different sites, and how exactly the overlay management protocol sessions are created between the devices. All these things are also will be covered in detail. So how are we going to exactly go about every week? So what is exactly the course structure here? So our course is once per week. So the live Zoom session will be one time every week, where it will be a 2-hour session. Although I always say in my introduction classes that it's not a time-driven class, it's a topic-driven class. Some topics might go slightly more than 2 hours sometime. Some topics might be less than 2 hours. So once the topic is finished, we are good with all the configuration that we need to learn, including the lab, then the session will be over, right? So it's just a rough idea that it will be around 2 hours. And that's why this is also just a rough idea, that 1 hour instructor-led topic discussion and 1 hour lab. So what instructor-led means is that when you come to this Zoom session, I will be explaining you a technology. I will take a topic. For example, the today's topic is DMVPN. Then I'm going to explain what DMVPN is and all the intricacies of the DMVPN, the details. And then there will be a lab followed by that. So there, in every Zoom session, you will see there will be a 5 minutes break in the middle. So we will do the theory part. Then there will be a 5 minutes break, and after coming back, we will do the lab. So in the Zoom session, you don't need to do the lab along with me. You just need to concentrate on learning, like understanding the topic in the theory part. And in the lab part, just understanding that how am I configuring the lab. So of course, when I'm configuring the lab, I will not be just typing the commands quietly. I will be explaining every single step. What are they asking in the question, and why the answer is the way it is. And then, of course, we will see some show commands also to check if that is working or not. So that's why this is also not strictly 1 hour each. Sometimes theory goes a little bit more. Lab is not so long. Sometimes lab takes more time than the theory. But just a rough idea is that this is how we will go about, right? Now, once we are done with the session, like let's say just to give you an example, today's topic is MPLS, right? So I'll send you a file like this where there'll be questions. So this is like a single protocol lab. There are instructions, what needs to be done. And I'll also tell you that which topology you need to use, and what will be uh, the diagram. So for example, this is a diagram for MPLS Lab 2, where router 1, router 2, and router 4 in the middle, they are representing service provider, where you need to configure LDP and IGP plus MPI BGP. And the customer or the CE side is router 6 and 7. And this side it is router 4, 5, sorry, router 5 and router 8, right? Connected to these provider edge routers. So I'll give you the diagram. I will give you the instructions, and in the Zoom session, I will be configuring this lab after explaining you, of course, how MPLS work and what are the important things you need to remember. Then we will do this lab step by step. That means I will read the question from here, and I'll configure it on EVNG according to these instructions. But when I send you this lab during the week, you can repeat this lab on your own. But I will also send you the solution file with this. So there will be a file where there will be configuration that you need to do according to the requirement of the question, right? So the reason I also send you the solution file is because you need to have the mindset of learning throughout this course. So don't think that, okay, when you are in the Zoom session, it's quite natural to have a learning mode because you are understanding new topics and watching me do the lab and explaining the configuration. So it's very easy to be into the learning mode. But as soon as I send the labs to students, I see many times they try to do it without looking at the solution or try to remember everything from the session. But that's not how it works. You still have to have the learning mode when you are doing the lab, because remember, you only test yourself when you go to the CCIE exam. Before that, it is all learning. So when you are doing MPLS lab and you get stuck somewhere, feel free to go and check the solution file, what exactly is the configuration for that. And if you don't understand the solution, or if you think that you have a different point of view on that, feel free to get in touch with me and discuss about this. Send me an email with the details, or there is a Facebook group for all the students. You can post your question there as well, which can help other students as well. So the idea is that anytime you get stuck, make sure that you go and check the solution file, or even you can watch the recording of the session, because that time also you are learning. And whenever your brain gets stuck on something and you quickly provided the solution that, okay, this is what you are looking for, so it will remember it for the next time, right? So it's, don't try to test yourself until you have ample practice done. So even during the week, you just need to make sure that you are doing these labs in the learning mode, right? Not into the testing mode. So don't test yourself right away. Of course, if there is any issue, you can refer to the solution file. And if the solution file is not clear, you can get in touch with me. Or also you can watch the recording. So this is another great thing about this course is that you get the access to the recordings for the lifetime. There's a lifetime access, although the recordings will not be from this class, because we have this CCI class. We have so many CCI classes happened in the past, and even this year also we had many CCI classes and currently running also. So what happens is that since the topics are same, we don't keep the recordings of every class individually. Instead, you will see the recording from one of the previous classes, but the content will be same, the lab will be same, the solution will be same, so you don't actually miss anything there. And whatever the information you need for the lab, you will find in those recordings easily. So how can this program help? I think this is something we have discussed already at length, that the main thing missing in a lot of programs is practice, and actually a phased practice, so that you have some time to practice everything slowly and not everything within 5 to 10 days. So we actually use the plan by using, we actually follow the plan of using single protocol labs configuration with the examples. And the solution files are always with you. You can always refer them. And of course, in every session, at the end of the session, there will be a short Q&A session where you can ask some questions if you have. But if you have more detailed questions, like you want to show configuration or there is some issue in your lab, you can always use Facebook. There you can paste paste the screenshots or configuration, or you can send me the details in an email. So that is a better way for more detailed questions or some troubleshooting questions. But some normal questions, you will always have a Q&A at the end of the every session, so you can ask it there. Of course, we have the SDN covered as well. Programmability and automation is covered. And full actual exam like multi-protocol labs to practice. Couple of labs we will do at the end of this course. And of course, troubleshooting tips. Troubleshooting, I will give you troubleshooting tips every now and then. But the best troubleshooting tip is that your fundamentals of the technology or the topic must be very clear, how exactly it's supposed to work. So if you know how it's supposed to work and there's a deviation from that, it is not working as it intends to be, then you know what to fix and where to fix it, and then it to make it again in an ideal configuration. That's mostly what troubleshooting is. And of course, you will have my support throughout the course. So this is another very important thing, that most of the courses available online also, they don't have much support. So you are on your own. Once you get the recordings, if you have any issue, you might send an email, you get a reply in a week or something. So or you have to rely on the forums, online forums for your technical questions. Here, I am actively involved in this course. So it's not a pre-recorded course. We will have a live session every week. And I will be available throughout the week. If you have any questions, shoot me an email or send me a message on the Facebook group, right? So you will get the answer from there. And lifetime access to the class recordings. So let's say if life kicks in and you somehow cannot complete your CCIE now, and a couple of years later you think, okay, I want to do CCIE now, I want to finish it, and there are few new topics added by Cisco or some old topics removed. Basically, the structure or the syllabus is modified. So don't worry, we got you covered, because every time there is any change, we are going to include that, and we are going to upload those new videos on the portal. So since you have the access to the class recordings for lifetime, any updates into the CCI exam also you will get anytime into the future as well. So you are future proof basically as far as the CCI is concerned. So what kind of tool are we going to use or tools are we going to use to configure or to practice all these labs? So we use EVNG on VMware, as you know, and EVNG is the free software, right? It's an emulation software. The difference between simulation and emulation is that simulators actually mimic the real device, but emulators actually use the real operating systems, internet operating systems in the backend. Just the front end is not a hardware; it's a GUI, it's a software, right? So that's why it is called an emulator. And EVNG is free. EVNG.net, you can go and you can download the software, but it's just a shell. So you will have to procure the routing and switching or SD-WAN images from somewhere. Then you have to copy it into the backend Linux system. You have to license them. And once all this is done, you have to open the GUI of EVNG and then start creating the topologies, right? So you will have to think, okay, how many routers and switches do I need to connect to practice important things in OSPF or BGP or IPv6? So to make sure that you don't have to waste time on all these things, we have already pre-compiled an OVA file which contains the EVNG, has all the important images of router switches copied into it, licensed already, and we have created the topologies also. So you can directly concentrate on the configuration and on the technology that you want to learn right from day one. So we actually take out all the guesswork or trying and testing part to practice things, and we directly go to the practice right from the first week, right? So that's why the topologies are already set in EVNG. And the lab files, as I mentioned, I'll send you along with the solution file so that you can actually practice them on different topologies that we have. And of course, during the off days in a week, you are encouraged to do the labs again and at least do it a couple of times and make sure that you are comfortable with the topic in hand. So EVNG itself is on the VMware, and OVA file I have already sent you. And for the first part, the recommended RAM, actually it's the minimum RAM requirement is 8 gig for the core technologies. But if you have 16 to 32 gig, that will be better, right? Because later when we do SD-WAN, it can be useful. 16 gig is okay. 32 gig is better, of course. And when you implement or when you import EVNG in VMware, just make sure that you set the RAM to the correct value that you want to use and set the first network interface to NAT, right? So you will see when you go to the settings of a virtual machine, you can set the memory to whatever level you like or whatever you can actually give from your system. And the first network adapter should be set to NAT. And then when you reboot or boot the machine, you should actually see an IP address. So you should actually come up to something like this. You will get to this kind of a screen where it will show you this Linux login. It's actually Ubuntu in the backend. So you don't need to log in here, right? Although the username is root and the password is EU. You can see default root password is EU. That is what you have here. In case if you want to play around with the backend Linux. But for this class, you don't need to. Why did you boot this is to note down this IP address. So you will see an IP address here if you have selected the NAT as the first adapter, and you note down this IP address, and then you open this into a browser. So when you open this IP into a browser, you will get to this screen, which is the EVNG login screen, the GUI of EVNG. That's where we will have all the topologies. And again, in the first week of the recordings on the portal, 0to-it.com or MyKajabi, you go to or karatul.mykajabi, you will see that the first week has a video also, EVNG setup video, which will have all the details of how to step by step do this importing OVA and everything. So you can find this information there as well. But yes, once you reach to this GUI, you log in with the username admin and password EVE. And when you sign in, you will see actually a bunch of labs and a bunch of topologies. Sorry. So these topologies are used for different labs that we will do. Like if you are doing a MAC address lab, or if you are doing a spanning tree lab, or span RSpan lab, VLANs, or any of the routing labs, we use this base lab for that. And multi-protocol lab that I was showing you is here. You can see you click on open and then you get to this screen where you can go to the more action, start nodes, stop nodes, wipe the previous saved configuration, and go back to the base config. Basically, all these things you can do here, right? So this is something you can do by using the OVA that I sent you by importing it. One thing though is that if you start a particular device, let's say you start this one, router 23, and you want to click on it so that the putty session should open, like click and then open the putty session. For this, you will see that the Dropbox link I sent you, it has an OVA file and also it has a Windows client pack, EVNG Windows client pack. So make sure that you install that as well, because once you install that, you will actually see a folder in your C drive. Let me show you here. In the C drive, you will see under the program files, you will see eve-ng folder. So the Windows client pack, the eve-ng Windows client pack actually installs all the supporting softwares and important registry keys that you will need to link the telnet client to the browser. So when you go to C program files eve-ng after installing the Windows client pack, you will see a bunch of files here. For example, the software that we will use to connect to the devices, PuTTY, is also here. And most importantly, you will see a registry file with the name Windows 10 64-bit PuTTY. So let's say you open the browser, and in the browser you click on the device and nothing happens. It's not opening the putty for you. So that means your browser is not linked to the default telnet client putty. So to do that, you can then double click on this registry file, Windows 10 64-bit putty. Don't worry if you have a Windows 7 or Windows 11, it's just a name. It will work in all cases, but it is ending with the keyword putty. You double click on it and you click on yes, install it into the registry, and then you should be able to click on the device in the GUI in the browser to open the telnet session, right? So that was just an example of EVNG that we will use. So what's expected from your side? So from your side, just show up in the class every week, do the labs, be consistent with the labs so that you gradually increase your knowledge and confidence. And of course, you are encouraged to ask questions whenever you have any doubts, because that's the beauty of this course. It's a live course, interactive course. So you can ask questions whenever you have any doubts, right? And of course be consistent in your uh, practice so that you can see your results, right? What happens initially, you might not see results immediately, just like when you go to a gym, you don't see six packs in a couple of weeks. You have to keep on working, or you don't see any muscles, but it is happening, right? Internally it is happening, something has started changing. That's what will happen if you keep showing up and keep doing the labs, right? And you will see like a magic, it will start making sense more and more once we go further. So that's it from my side. Last thing about myself, my name is Arpit Pandit. I have been a trainer for last 18 years, and mostly I have been involved with Cisco, but before I also did some Microsoft, and I also teach Linux, cloud services, Juniper, uh, SD-WAN technologies, some non-Cisco SD-WAN as well. I have more than 11 years of CCI training experience. Now, actually, it is 12 to 13 years. I have to update this. And I have two CCIs, routing, switching, and service provider. So I actually basically love Cisco stuff, and really like to teach, really like to actually explain the concepts and how actually things work, right? That really gives me a lot of pleasure. And I also have a lot of practical experience from consultation work with major service providers. So I do get involved every now and then to provide consultancy for different projects. And these projects generally involve newer technologies. Sometimes they involve pure Juniper networks in the backend. Sometimes they involve onboarding a new customer and connecting their Cisco router to the provider edge SD-WAN device. Sometimes it only includes the SD-WAN devices. So it's a good thing that these things are there, so that I can include some of the examples from here into the classes every now and then, right? So having said that, let's get started. Thank you. This was a smaller session today, just introduction. But from next week, we will start the sessions, right? So the first session will be IP addressing and subnetting. So you will still not need EVNG next week. So you still have time if you haven't set it up, or if you need a little bit more time to set it up. Next week will be a theoretical lab, but from later on, we'll start the practical labs as well.